Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is swap nodes in pairs. We were given a linked list and we're asked to swap every two adjacent nodes and return its head. And we must solve the problem without modifying the values in the list's nodes. In this case, if we were given a linked list like this, we cannot just override the value of each node to make the so-called swap. We have to really swap the pointers. Okay, that's what it says. So basically we were given 1, 2, 3, 4, and we're going to swap 1 and 2 to form 2, 1. Then swap 3 and 4 to form 4, 3, and then connect this part, the first part and the second part. Okay. And if we were given a null list, we are going to return the null list. And if we only have one node in the linked list, we're going to return it as well. And if we have odd number of nodes in the linked list, we're going to return from the start. Okay, we're going to swap the first two, then remain the rest as it is. Okay, so how can we solve this problem? So basically, we can solve this problem in two approaches, which I will be going through today. So first and most intuitive thought is using recursion. Okay, so first is using recursion. Why would I use recursion? So if you think about the problem of reversing the linked list, if we were given a linked list like this, 1 to 2 to 3, we can do the swap here. Okay, so like if we know the resulted head of the reversed second half of the linked list, except the head, we can just modify things here to reverse the whole list and give the rest of the problem to the recursion function. Okay, so we can do the same thing here. If we have something like 1, 2, 3, and 4, we don't care about the rest. We can only care about the first part. So if we can swap this and connect the swapped second node to the reversed second half, now we're going to have 2 pointing to 1 pointing to whatever it is. Okay, reversed second half. Okay, so in that case we can reverse all of the nodes in pairs in this linked list. Okay, so yeah, with that said, we can write it down. So the stopping function, the stopping condition is if head equals to null or head.next equals to null. That means we have only 0 or 1 nodes in our linked list. We're going to return the head. Okay, we're just going to return it, and then we can use a subhead to we can swap, like I said, swap the second half. Okay, so in this case it would be head done next, because we're swapping this part, and the head is this node, which is head.next. Okay, so if we know the subhead, we can do some operations here. Okay, so let me record the second node, which will be head.next. This will be 2 here, and our first will be our head. Okay, so now we can do the reversal here. So we have the first node, which is the head. Head.next will be the subhead, right? That's the connection here. And then we are going to modify this pointer. So the second will point to head. Okay. Second.next will point to head. And we're going to return second, because the second node is now the head of the reversed linked list. Okay, let's see if it works. Yeah, passes the test cases. Now let's analyze the complexities. So for type complexity, it should be ON, because we're traversing through all the nodes in this linked list. And for space complexity, we have N, because we have a call stack here. Okay, we have a call stack. So that should be it. All right, perfect. And then I'm going to use another more optimal in terms of space, but not so intuitive, because we have to modify the pointers so many times. So it can be a little bit tricky. But let's take a look at it. So the same question here, right? And now we're going to swap it. But now we are not going to swap using recursion. We're going to do the iterative way. Okay, so iterative way, in that case, we need a previous node. If we know the previous node, we can swap here, this part, and then reset the previous node to this one, and do the iteration for the next pair. Okay, so in this case, the most common stuff we're going to use is the dummy node. So I'm going to use a dummy node here to be our previous node, and I'll connect this dummy node to the head. Then I will initialize a previous node to dummy. At the end, I will return dummy.next, but I will not do it right now. Okay, so how should we do this? We know the previous, we know the head, and we can save the head.next and do the operations here. Okay, so let's see, when does it stop our function? Because our function goes on and on and on, there has to be a stopping point. Okay, so while this goes to the base case of our previous function, which is head doesn't equal to null, and head.next doesn't equal to null. Okay, in this case, we're good to go. Head.next doesn't equal to null means if we have only one node left, we're not going to process any further. Okay, so let's record it. First equals to head, second will equal to first.next. Okay, so now we have this as the dummy node, and this as the first, and this node as the second. Okay, yeah, I'll just do it like this. Okay, good. So now we can process it. The first thing is we're going to swap these two, right? Swap these two. So previous.next will be the second node, and the first.next will be second.next. We're connecting 1 and 3, and now we can connect 1 and 2. So second.next is first. Okay. Yeah. So in this case, now we have something like this. We have previous pointing to 2, and pointing to 1, pointing to 3, pointing to 4. Does that make sense? So previous.next is second. First.next is second.next. Second.next. Okay, and first, second dot next is first. So we effectively swap this part. Okay. Next, we're going to reinitialize the position of the previous pointer. Okay, we're going to point it to the first. Okay, so here I'm going to use previous equals to first, then I will reset the head as well, because the head was here, but now we have to use the head to process further. Okay, so head will equal to first on next. Okay, yeah, so that makes sense because we're processing over the pair, over one pair, and we reset the starting condition and we process further. Okay, so like I said, it should give us the right answer, and we're going to return dummy.next, which remains the original head. Okay, the swapped head here. Run it. Okay, it passes the test cases, and let's analyze the complexity. For time, it should be ON as well, but for space, since we're not using any extra data structures, it'll be constant. Okay, this will be the most optimal solution. Thank you so much for watching. I think it passes all the test cases. And if you like the video, please like and subscribe to my channel. I'll see you in our next video.